So hello and welcome back. So in the previous videos we were talking about some concepts in, like, for example, voltage and voltage drop and current and the fact that, for example, current at any point in a circuit is the same no matter where you basically measure your current, and of course the if what happens if a circuit is broken, and then what happens to the full voltage of the battery at different points in the circuit and things like that. And of course we also talked about the orientation of voltage drop, which was basically called polarity. So now I said that I would do some experiments here to show you what all of those things practically are and what we can actually do with them. Now this is the first time actually that I'm doing videos on these using this setup, and so you will have to excuse my, if I have any sort of problems, you'll have to excuse my camera setup and things like that. I'll have to basically work with it and find some sort of I'll have to find some ways to work with them efficiently. So what I'm going to do is that, first of all, we are going to work with these multimeters. So this is a multimeter that it can basically measure voltage and resistance and current, and also heat. And these are the different buttons that you use in order to set it to different modes. And these are different ranges of this multimeter. Again, this is another multimeter. These are of course very old multimeters, but the precision on this on these two multimeters, for example, is much higher than. Oh, I have to. Let me actually go to change the video over here so that I know what I'm doing. Okay. So but the precision on these multimeters is much higher than the precision on such a multimeter like this. So this is a very cheap multimeter, for example, $15 or $20 on eBay. You could get something like this, but although, for example, this one was very old when I bought it, this one is probably, I don't know, 35 years old at least, but still you would have to pay at least $150 for this multimeter on eBay, and the same goes for this. But anyway, it's not very different from, these are not very different from such a multimeter as far as we are concerned right now for our purposes. So if you want to set up a small electronics lab for yourself, something like this would also be enough for you right now, probably. Because if you want to get, for example, a new one, something like this, a benchtop multimeter, that would cost at least $500, $600, the cheapest ones. So that's that. And then we have also this power supply over here that I had to bring it back up here, because it was over here. It was right here and was away from all of these things, and I didn't want to have to basically move this camera every time. So I put it over here just for now, just for the sake of these experiments. So this we are going to use as a voltage source, and that's basically wherever, for example, in the schematic we have the schematic of a battery, for example. In that case, we are going to use this thing in order to supply the voltage and the EMF for us. And so now let's see how this thing goes. So now that the first thing that I'm going to discuss here is basically voltage is the measure of specific voltage is the measure of, and I need to learn how to work with this camera. I've never done this before. Voltage is the measure of a specific potential energy between two locations. In layman's terms, it's the measure of push available to motivate electrons. So we said that, for example, we said that, for example, when you have, let's say that you have a circuit. Let's say that you have a circuit. You have a battery up here. And I guess I'll have to close this thing in. Well, it seems that right now this thing is not really helping me. So basically we said that, and I hope that I will not have to write too much now. Otherwise, let me just use a piece of paper, because I have to restart my computer, and so basically about voltage. Oops. Well, let me take care of this camera, and I'll be back in just a few minutes. Okay, so I guess this takes care of the problem for now. So voltage is basically nothing but, well, when you have a battery, you have a voltage source, and that creates that EMF for you. And that EMF is actually the force that pushes electrons around in your circuit. Meaning that if you have a circuit like this, you have a battery over here. In this case, it's our power supply up there, and then you have, for example, any sort of voltage source is of course denoted by some sort of EMF, or for example 9 volts or 12 volts, and in this case we are going to assume that it's going to be the DC voltage or DC direct current, and of course there is always some sort of polarity, meaning that, for example, this is going to be positive and this is going to be negative, based on meaning that this dash, the longer dash, is always representing the positive pole, and the shorter dash is always going to represent the negative pole. And that pole is, for example, this. That pole is, for example, these two poles are, for example, these two poles on a battery, for example. If you have this a 9-volt battery, you can see that here you have this pole over here is a positive pole, and this pole here is the negative pole. And even on the battery, you can hopefully, in this camera of course you can't, but hopefully you can read that this says positive and this says negative. And that's basically what is meant by these two. Now when you on a power supply, it's going to be a little bit different. Of course, not very much different. So you can see that here I have these outputs here. There is one output here, one output here, and one output here. And of course, you're not going to be able to read here, but let me bring a little bit closer here. So if you can see what's going on this power supply. So here you can see that there is a banana plug over here which is red, and there is a blue banana plug here which is basically negative, and this is positive. Again, positive, negative. Again, positive and negative. So that's basically the same thing that you see on the battery, and of course the same thing that we do in a schematic on paper here. So that's basically all the same thing. And well, there is let's say that there is a lamp over here in this circuit, and this lamp is connected to this battery, and of course, as long as the electrons are running all around the circuit, this lamp is turned on. So this is basically what happens, and these electrons are of course in the circuit, meaning that they are a part of the circuit, meaning that, for example, you have a piece of copper wire here, you have a piece of copper wire here, you have a piece of copper wire inside the lamp, and so on and so the whole circuit is basically a combination of free electrons, of course. And these free electrons, when they are motivated to move in a specific direction, then that movement, of course, that movement causes the lamp to turn on, and then but then there you need to, because moving those electrons needs energy. Those electrons do not want to move, and you want to make them move. So in order to make them move or cause them to move, you need to create some energy or consume some energy in that circuit, or give that energy some circuit, give that circuit some energy. So that energy is coming from this battery. Otherwise, this battery would not be required in a circuit. You would just have a lamp, and the lamp would simply be turned on, which of course makes no sense. But what this battery is doing here is basically creating that push in the circuit so that electrons can go around and basically so that the lamp can turn on. Now, what I have here is a lamp, and I got this from a friend of mine. And just to show you that there is nothing specific in here, where is my screwdriver? I will open this thing. Let me turn on my soldering iron as well. I need to turn on my soldering iron here, which is okay. So I want to open this, and so that I can take out the lamp, and this way you will know actually what the circuit is made of. So as you can see, there is a lamp in here that I can actually take out, and this is the lamp here. So on the lamp it says, of course I cannot show you on the camera, it says, and I cannot see it myself. It says R10 watts, 2 dV, R10 watts. So it's 12 volt 10 watts or 10 watts. So it's 12 volts 10 watts. So that's the rating of this lamp. Now I want to use this. Of course, if I use this battery, it's not going to last a long time. Let me actually show you what happens. So what I'm going to do, when you connect this lamp in this holder over here, there is actually a wire down here and this connector over here that connects the two poles of the lamp to these two wires. And then you connect these two wires to somewhere, and then you'll have the lamp turned on. So what I'm going to do, I want to connect this piece of wire to the lamp so that we can actually work with it. So for connecting this to this, you need a soldering iron, some solder, which is usually in this form. It's like a thin piece of wire that's usually on a reel like this, and then you need a soldering iron. The soldering iron looks basically something like this. You see this thing over here? This thing over here. This is a soldering iron. This is a base or station on which you can put it in, and then you can of course work with it. So then in order to connect, for example, this piece of wire to the two ends of this lamp, you can see that on this lamp there is one contact over here and another contact over here. So you can actually connect your piece of wire to anywhere, to the body of this, to this place, to anywhere on this body, and the other piece of basically I have two wires for a lamp, and the other wire goes to this center over here. So what you need to do is actually do it simply like this. So you need to kind of do it like this, and give it some solder, for example, and then you can see that this place over here has already been soldered before. So I can use this, or so I can use the same place. I can use the same place and put some new solder over here. And you can always use your fingers and your hand in such a way that they work for you. So I basically hold the solder with these two fingers, and then use these two fingers, this one and this one, in order to hold whatever it is that I'm holding. So for example, to solder this, I use it with these two fingers, and then I use the solder, I hold the solder between these two fingers, and simply I can solder like this. Otherwise you would need these benches, not benches, but these it's called a vise, I suppose, a bench vise. There are small bench vices that you can use on your bench. Sometimes they come in handy, but you don't need it for soldering. Okay, so now what I'm going to do is I want to connect these two wires to the lamp. So I'm going to, first of all, a little bit put them together like this, and then you need to put a little solder on them. Otherwise your connection is not going to be very good. And then you need also a pair of side cutters to trim these, and something like this. So now these are ready to be soldered to the lamp. So then you can, again, I use the same, I do it in the same way. Now instead of holding the solder between these two fingers, I hold this piece of wire here, and again with the two same fingers holding the lamp, and with the other hand I simply start the soldering this way. And you want to blow on it probably, because otherwise it takes a few seconds to cool down. And then the next one is like this. So you put the wire over here, and then if you touch the soldering iron to that point, now the lamp is simply connected to this piece of wire. Okay, so now what I want to do is, so now the other end of this is already the insulation has already been taken out. And now if you want to make sure that this connection, that there is no problem with this connection, so you need to do a simple test. So a lamp like this, a simple lamp like this that has a filament inside it, it's just a piece of wire. If you look through the glass, you'll see a simple piece of wire between two terminals, and of course there is no oxygen in there, or there is no air in here, so it doesn't burn. It's vacuum, and that's what a lamp is. And a lamp is usually it has some sort of resistance. It's basically a load here. It's something that resists the flow of electrons here. So it has some resistance, and of course we are going to get to resistance shortly in our book. But for now, you can have a simple any sort of multimeter. For example, I could use this one, and I put this in ohm. And you can see this sign over here, which denotes ohm, and that's used for electrical resistance. And then you need a set of probes always. So I put my probes over here, it's always usually one of them is common and the other one is the different functions that you want to use. For example, here you see that there is a guard or 0 over here, and there is volt, ohm, and ampere. So I go to ohm, and now I have, this is a auto-ranging multimeter, meaning that you don't have to change the, you don't have to choose any ranges, any specific ranges. It can sense whatever it is doing, it can sense it itself automatically. So I put it on, of course it can be made manual, but I don't have to do that. I put it in automatic, and automatic here, and here this button you use when you want to use the manual ranging. And now if I touch the two leads, you can see that the resistance in this piece of wire from here up to here, it goes all the way from, this piece of wire is probably, I don't know, a meter long, or a meter or 120 centimeters or something like that, and I'm touching the two ends over here. So, and the resistance as shown here is 0.002121, and I can probably hold this way. No, it doesn't work that way. I can hold it this way so that I can read it and it stops changing. So it's 0.00207. So 0.00207, and that is kilo ohm. Kilo ohm means that when you have kilo ohm, then whatever you have here, and I hope that and of course in the next video our scratch pad is going to work on the computer, so you don't have to read this over here. So 0.00207 kilo ohm is the same thing as kilo means 10 raised to the power 3. So this means that this is equal to 0.00207 into 10 raised to the power 3 ohm. So now 10 raised to the power 3, so you move this decimal point to 1, 2, 3 decimal places over here. So it becomes 2.07, for example, ohm. That means that the resistance of this piece of wire is probably 2.07 ohms or something like that. But we can do another experiment as well. I can simply take out this thing over here and use a very short, very short piece of wire. For example, this piece of wire, and short out these two terminals. Let's see what happens. Let's see what happens if I short out the 0 and ohm here. I will get so I guess you could, there is a possibility for me to there is some way to make this 0 or calibrate this actually, but I'm not really worried about that right now, because if I were to calibrate this whole thing, then okay, so it's 0.00337. So for this piece of wire, it's giving me 0.00037 or 38. So that means that 0.00037 kilo ohm, and it is kilo ohm because you see that there is a kilo up there. This is how this multimeter works. It's a little bit weird. You always have to convert from kilo ohm to ohm, even if you're measuring something of very low resistance. So then it is 0.00037 into 10 raised to the power 3 ohm. And then for this part you need to just move this decimal place 3 places to right, because it's a positive power. It's a positive power, so you move this decimal place 3 places to right, so it becomes 0.37 ohm. So it's something around 0.4 ohm. It's not even half an ohm or something like that. So now this multimeter is showing me that the resistance of it's probably, I could probably say that the multimeter has to be calibrated, and of course because it's for this piece of wire, it's giving me 0.38, but of course you can always make this 0 to get rid of this kind of thing that you're reading here right now. And if I open this right now, if I open this and use my own probe here, so I go to 0, and I go to ohm, and then this probe, if I short circuit this probe, it's giving me 0.0165. So it's 1.66 ohm. Well, it's okay. Now, what I wanted to do here is that, well, I had this lamp, and I wanted to know if this lamp is still any good. So a lamp has some sort of resistance because it's a piece of wire inside. It's just a piece of wire, like for example this piece of wire, and you can of course measure the resistance of this piece of wire. You put one of your leads here, and the other lead you put it on the other end, and you can see that the resistance is 2.38, around 2 ohm. But of course you're reading the resistance of the probe as well, but it's around 2 ohm, for example. Let's say that just around 2 ohm. So what I meant to say is that you can of course measure the resistance of a piece of wire. So by the same logic, I can put my probe over here, and I can put the other end of probe over here, and you can see that the resistance over there is around 2.9 ohms, 2.93 ohms. So whatever you read over here, you just move the decimal place 3 places to right, because it's giving you kilo. You see, it's giving you kilo. So you just move the decimal place 3 places to right, and then you're reading ohm instead of kilo. So it simply means that this lamp is good, because it's I'm reading the resistance of the wire inside. And now I can actually do the same thing at the end of the wire here. So what I'm going to do is, instead of touching my probe on the lamp itself, instead of touching probe over here, I'm going to touch it on the other end of the wire. And more or less you're reading the same the same resistance here. That means that the lamp is good and the wire is connected properly to the lamp. Okay, so far so good. Now we need to, for this part of the circuit, so now this part of the circuit is taken care of. The lamp is taken care of. I just need, and these pieces of wire are already taken care of because I have connected these two pieces of wire to the lamp, and this is, here I have only two pieces of wire. Now what I need to do is take care of the battery or the voltage source. That I will do in just a few seconds. I will take a few minutes rest. I'll be back with you. Okay, so now before I go any further with this video, I just need to take care of a problem. So we said that, so if you paid attention to the way I made these measurements with this multimeter, so when I set this multimeter to on and I put it on auto ranging, meaning I don't have to touch the range anymore, then when I touch the two leads together or the two probes together, I'll get something around something around 1.6 ohms, and that must be coming from this wire, because it's a long piece of wire, and the multimeter itself might not be zeroed. Now if I do the same thing over here, and there is a specific key combination that you can do on this multimeter, and then you can zero it. I know that, but I have forgotten how to do it. Now if I do this with this multimeter, let me actually use the same probe so that I know what's going on. So this was around 1.7, around 1.7, and if I connect the same probe to this multimeter and set it to kilo ohm, and then if I touch the probes, this is, so if here I can actually choose, I can actually make changes to the range. So now I'm just keeping this connected. So here I get, and this is in kilo ohm again, so I have to divide by 1000, or I'm sorry, I have to multiply by 1000 to get to ohm. So this is 2.1 ohm. Over here I get less and less precision as I go along. So here I get 0, 0, and 0. So, but here, over here, I have all the precision available on this multimeter, and this is showing me 2.1 ohm. So again, I'm getting some resistance over here, and then I can do another experiment. I can put it on full precision and then touch these two terminals together so as to rule out the resistance coming with this wire. And let's see what happens there. And I'm getting around 0.2 ohm. So this multimeter is much closer to reality. So this must be zeroed. Now, this is one thing. And if you buy multimeters, for example, something like this, these simple multimeters here, they usually come with a probe, something like this. They usually come with a probe of this quality and this length. And so Now let's see what happens here. So if I connect this to volt ohm milliamp and connect the other probe to common and set it to, for example, and this is, as you can see here, I have ohm, and set it to 200 ohms. And you can see that here I don't have the luxury of auto ranging that I had over here. I had to choose my range, meaning that here I have 200 ohms, 2 kilo ohms, 20 kilo ohms, 200 kilo ohms, and 2 mega ohms. So here I have to choose and go up and down to get more and less precision based on the resistance that I have. So if I go to 200 ohms and short circuit this, I'll get something around 0.04 ohms. So 0.04 ohms. So, and there is of course no way for me to zero this multimeter unless I open this and play it with some sort of potentiometer inside, which is not what I want to do. On the other hand, there are some other types of multimeters which are basically analog multimeters, and on these types of multimeters you have this potentiometer down here, and when you read it, it says ohm adjust, so 0 ohm adjust. So this does the 0 ohm adjust for you. So how does it work? They usually come with a probe of very low quality, and the probe usually doesn't work after even a few days. It gets just disconnected. Now, for example, this probe came with one of these, and then I had to break this part and then make the wire shorter and then solder it back again to this tip, but it works. It's not a problem. You can always buy good probes on, for example, on banggood.com. You can go get yourself a pair of good probes, and that would work for you for at least a few years. Now if I set this to ohm, you can see that there is the ohm range over here, and here it starts with ohm times 1, ohm times 10 times 100 times 1k times 10k, and here is off. So if you set it to, for example, ohm times 1, so then you can see that up here on this scale you can read your ohm up here. It goes from 0 to infinity, and then depending on depending on this selector down here, you need to multiply whatever you read here by this number. For example, times 1, meaning that whatever you read here is the resistance of whatever it is that you're testing. If you're set it to 10, to times 10, whatever you read here, you have to multiply it by 10 to get the actual resistance of the part that you're testing. And times 100 times 1k times 10k, and so on and so forth. So now I set it to 1 times 1, ohm times 1. And you can see that if I short circuit the probe, you can see that the needle actually goes all the way just up to here. It's supposed to be 0 because, well, as far as I'm concerned, I have no resistance in this circuit that I'm testing. It's just the probe shorted out, so it has to be 0, of course. So what I'm going to do, and it does some sort of playing up sometimes, which is not a problem. And what I'm going to do is move this. So you see, if I move this thing, the needle keeps moving, and I can adjust it. So for example, let's say that this is 0 over here, and there is a piece of glass underneath the needle, and then if you use that piece of glass, you can you can read the scale better, because then you would rule out you could take care of looking at the needle at different angles. So now let's say that this is 0, and then if again I probe this lamp, so what I'm reading here is around 1 point, so it's not really easy to 1.1 ohm, something like that. So that's basically, or even something like this. Let me see. It's around 1.1 ohms. And now if I, for example, if I used, for example, this multimeter, if I use this multimeter up here to use to measure the resistance of this lamp, I'm going to connect, which is not possible, like this. So I'm going to connect this over here and set it to kilo ohm and full precision, and then now if I short circuit the leads, I'm reading 1.9 ohms. I'm reading 1.9 ohms. So there is a way, for example, with this multimeter to zero it somehow, and you can insert a screwdriver here. You can see it's increasing in this direction, and in the other direction it's decreasing. And I can go down all the way up to 0.9 ohms. I can go down all the way up to 0.6 ohms, 0.5. It keeps changing. 0.4 ohms, something like that. Okay, so but in real life you really don't need that much of precision. Now what I'm going to do, I just want to somehow wrap this video up. So now I simply want to basically test this lamp. So I touch the probes to the ends of the lamp, and I read something. Let's take this as perfect, and then it is 1.7 ohms. So I know that the lamp is actually not, it's connected. And then if I do it on the other side of the wire, on the other end of the wire, I'm reading around 2.9 ohms, something 2.4 ohms. So that means that the lamp is taken care of. Now I need some sort of voltage source, some sort of voltage source to turn this lamp on. So I'm going to what I'm going to do is come over here to this power supply, and turn it on one of the rails is not working. That's how it was when I bought it. I bought it secondhand on eBay. And you see there are two rails here. So there is this one rail up here, and one of them you can see that it says 0 to, over here it says 0 to 40 volts and current 1.25 amps. So this is one rail here, and here you can see that it says 0 to 40 volts. So if you put some sort of voltmeter up here, you will, I've tested this, you will get around, I put this to volt DC and around, go to 200 for example, and if you measure this voltage over here, you'll get around 60 volts here, 64 volts. So this rail, and you cannot, of course, there is no way to control it. It's just gone. You can see if I turn this, there is no way for me to change the voltage. It's just not working. Okay, so now this rail is not working. I need to do something later probably, or get another power supply. But one rail is okay, and you can see that here it says 0 to 20 volts, 2.5 amps. Current 2.5 amps and 0 to 20. Of course, it doesn't go all the way up to 2.5, but it kind of goes up to 1.5, I suppose. I hope so. Now, if I set we said that the lamp was 12 volts, 10 watts. So 12 volts, 10 watts, and I'm going to set this to 12 volts, and you can see that the voltmeter here, it's a analog voltmeter. It goes to 0 to 20 volts, and here it goes to 0 to 40 volts. So 0 to 20 volts, here is 10 volts, and then 11, 12 is all the way up to here. And then this is the current limiter. So the current limiter is going to limit the current that's output here. And the output that's related to this rail is, of course, these two plugs, these two banana plugs. So now if I set this to volt, for example, this multimeter, if I set it to volt DC, and if I go to all the way, for example, to 20, and if I measure this voltage, you can see that I have negative 12 volts, which is weird, and that is because I have connected the positive, the red lead to 0, which is not supposed to be this way. It's supposed to be this way. So now if I connect the red lead to positive and the black lead to negative, you can see that I see the positive 12 volts over here, and that is what is meant by polarity, meaning that you can have positive and negative voltages. So that is that. And so since now that I have my voltage set up, I can for example connect this over here. I can connect a piece of wire to this output and now connect it to the lamp. So these are actually the two pieces of wire that we talked about. So you see here, seeing me? So you see here that you have one piece of wire coming from the power source, positive pole going to the lamp, one piece of wire going from the negative pole going to the lamp. And that becomes basically this piece of wire over here along with this piece of wire, and when you connect them together like this, you will have your lamp turned on like this. And of course, shorted out. And of course, now that we are here, we can do a couple of experiments. So now you can see that this lamp, now first of all, let me actually measure the voltage here. Let me see what the voltage is, because this had some problems. So now I'm going to measure the voltage directly on here, and I'm getting 11.912 volts. Okay, so the voltage is not sinking. So now if I basically, you see that the voltage is over here, and if I set this switch to amp CC, if I set it to amp, so right now it's set to volt, right? And I could set it to amp, and if I did so, this would become a amp meter instead of a voltmeter. You can see that there are two scales over here. I have a scale up here for a voltmeter, and down here I have a scale in red. That is an amp meter, which goes 0 to 2.5 amps. So now if I set this switch to amp, this becomes an amp meter, and it gives me, and it tells me that I'm drawing a current of 0.5, and this is we're getting a little bit hot over here. So this is telling me that I'm drawing a current of around 0.5, 0.6, 0.7, 0.8, 0.9, and 1. So around 0.5, 0.7, 0.7 amp over here, which is 500 milliamps. Okay, so now if I want to actually, first we can measure this current over here. And how do I do it? I put this lamp down here, and it's turned on. You can see that it's drawing some current, and I set this to milliamp, and I set this to milliamp, and so this becomes an amp meter. And I set this probe to amp as well, and so this becomes an amp meter. Now if I connect this amp meter in series with this power source and the lamp, then I will be able to measure the current that the lamp is drawing from the power source. So I disconnect this. So let me put this lamp up here so that you can see it. So I disconnect it. Now the lamp is turned off, and if I connect it again, the lamp is turned on. So in series with this, meaning that I have two probes for the amp meter, I put one probe over here. And I connect the other probe. I put one probe over here, and I connect the other probe over here. And well, you can see that the multimeter is not showing me anything. So I go one up and up. So now I'm reading 652 milliamps. 652 milliamps is around the same thing that we said, around 500 milliamps. 645 milliamps, or around half an amp. So that's basically, let me go up actually. So this amp meter is a little bit weird. So now let me connect it to the other multimeter and see what's going on here. So I set this up as a multimeter, as a amp meter. So I set it to amp DC, and put this to 0 and this to amp, and you can see that I'm reading 680, around 680 680 milliamps. 680 milliamps. So that's basically what's going on here. And I'm going to turn this off, but the problem is that it seems to me that these two amp meters were actually somehow changing the amount of light coming out of the lamp. So there has to be something there that we need to figure out later. So that's basically my circuit over here. That's basically this circuit over here. We talked about the power source, we talked about the current, we talked about a lamp, and we did some sort of soldering over here. We set up our power source, we set up an amp meter, we set up a voltmeter, a couple of different multimeters, and so in the next video what I'm going to do is basically set up some circuits to show you what is meant by voltage drop. I would need to set up a few resistors or things like that to show you how that works. So thank you for watching this video, and I'll see you in the next video. Thank you.